Good afternoon, everyone. The webinar is about to begin. Please note this call is being recorded. The SIOR Technology Committee is pleased to present this webinar, The Autonomous Future of Real Estate. We are very pleased to welcome all of you to this program. Please note that today's call is being recorded and all participant lines will be muted during this broadcast. We also ask during this call you do not place your phone line on hold at any time. The recording of the webinar will be posted to the SIOR website. Today's webinar will last up to 60 minutes and will include time for questions and answers. You may submit a question at any time by typing it into the box on your dashboard marked questions. Questions will be answered at the end of the session during the Q&A period. If your question is not answered, the presenter will follow up with you separately from this broadcast. If you're experiencing technical difficulties, you may chat with me privately via the box on the dashboard marked chat. And now it is my pleasure to introduce from SIOR's Technology Committee, Jim Klein, SIOR. Jim, let's get started.
Thank you, Lizzie. This is the start of the third year of the SIOR-MIT relationship. The goal is to find and use tech that can help all SIORs. I'd like to thank Tim Brodigan, Gary Shacker, Steve Weichel, Alexis Fermanis, Steve Kapp, and the Board of Directors. The SIOR Tech Committee is pleased to welcome James Scott, JD, Master in Real Estate Development and a Master's in Business. He is the lead researcher at the MIT Real Estate Innovation Lab, where he works with data providers to link design and innovation to financial performance in the built environment. James, thank you for joining us today.
Jim, thank you so much for that very kind introduction. First of all, good afternoon, everyone. I'd like to thank the SIOR for having me this afternoon. And I'd like to welcome everyone to this first SIOR webinar of 2018. We hope to do 3 of them this year. And I hope that all of the members find this as a useful tool. It's the intention of this particular webinar is that the members, and hopefully we'll get an awful lot out of this, so we're really looking forward to it. First off, I want to outline exactly where the aim of the webinar this afternoon. My aim with this particular webinar, as the first one, is to give a greater understanding to the technical terms that are thrown around out there in the industry at the minute. We hear an awful lot about them, and people use them on a daily basis. But without a kind of any sort of real great understanding. So I want to try and give people a really clear idea of what they're actually talking about. And I want to try and use an awful lot of everyday analogies so that people can have a clear idea of what these technologies are. It would be what I would really love to come out of this is that the members that are here today to think about the effects of automation and the effects that the automation is going to have on the industry. I think hopefully at the end of this, with having a clearer understanding, you're going to be able to help your clients understand not only their needs today, but their needs going forward and in the future, which is always, at the end of the day, being a broker is a relationship business, and being able to understand your clients' needs, I think, is a very, very important part of that. The webinar itself, I'm going to try and not use any complex terms. I'm going to try and make everything as easy as possible. But there are going to be no science or mathematical formulas. There will be one slightly technical slide, but I promise if you stay with me and you don't fall asleep as I try to explain it, it will all make sense. Okay, so let's get started, and here we go. So I think this is a great image here for us to kick off with. This is, I'm not sure if a lot of you will have seen the movie Avatar back in 2009. At the time, it was the biggest movie of all time, directed by James Cameron. In that movie, we had a situation where there was a person in a robot like the one in front of us walking around and being able to lift things, and it was used in a military purpose. Well, that was in 2009, and at that time, that was science fiction. Here we have Jeff Bezos of Amazon actually in the Method 2 robot and working in it as of last year. That's how far we've come. Automation is no longer kind of an idea in the back of people's heads. It's really, really here. So what is automation? Well, to give a kind of a clear definition of it, automation is it's the creation and application of technology to make an apparatus, a process, a task, or a system operate automatically. It involves a very broad range of technologies, but it's in the advances of robotics, artificial intelligence, and machine learning that have sparred this topic to the forefront of conversation today. I personally like to think about it in kind of a much more simple terms, in terms of hardware and software. The robotic side is the hardware. It's the element of automation that we're going to be able to see with the technical side, the large robots and the large assembly kind of robotic construction that we're going to see in the years to come. The other side of it is the software side. It's the brain element. It's the thinking about it, and that stems out of artificial intelligence and machine learning. So where we're going to go with that is, and we're going to try and explain what these terms mean. And this is, unfortunately, this is the only slightly technical part of the webinar. And I promise, if you stay with me, it will all make sense, and I'll hopefully be able to make it very, very clear. So why is this important? I mean, why is automation and artificial intelligence becoming so kind of prevalent in everyone's conversation? Like we've all heard about artificial intelligence for literally most of our lives. AI was a term, that was coined in 1956, I think, at one of the Dartmouth conferences, and it's been thrown about in movies and in literature for a long time, but it hasn't really affected us. It hasn't affected our daily lives in any real significance. We're a long way from, the idea of like the Terminator machines coming and using them in the army, or C-3PO or R2-D2 from Star Wars. We're a long way from that, and it never really affected us with all the talk and clamor about, it's going to take jobs and it's going to reduce people's ability in the world. But we're hearing that all the time. But suddenly again, in the last 2 years, we've seen a major change in technology, and there's a very specific reason for that. Artificial intelligence is the wide gamut of what we're talking about, and it's very well displayed in this particular image, in that it encompasses machine learning and deep learning, and these are all part of artificial intelligence. It's a field of computer science that specializes in developing systems that exhibit sorry, excuse me for coughing, exhibits some sort of form of what we call human intelligence. What we kind of look at on a daily basis, and this is going back to the 50s, what we see as tasks that are done far more efficiently and kind of faster and better than what humans can do. And the simplest example of that with artificial intelligence back in the day was the calculator. I mean, a calculator can probably add, subtract, and multiply numbers far quicker than any of us. But quite simply, that's all it can do. It's very limited in what it can do. Again, the assembly lines that were started to develop in the 70s and 80s throughout the United States, and then in Japan, again, like brought to a new level in the 1980s, they're all part of an artificial intelligence. And again, like a calculator, they're programmed to do one specific task. And it's a very simple task. So when you think about an assembly line, you think about a robotic arm, and it's picking up a box and it's lifting it from point A to point B. That robotic arm can go, and it can do that very efficiently and can do it all night and 24 hours a day, 7 days a week. But if you move that box that it's supposed to lift from point A to point B to just outside of the coordinates that it's supposed to lift the box from, it can't understand that, because it's programmed to do a very specific thing at a very specific time. Well, that's obviously quite limiting. Well, so the next stage of evolution with automation has been machine learning. And that's probably where we've seen the most development over the last few years. And it's a subfield itself of artificial intelligence. What it does is it develops a system that learns. It learns, and what it happens is that it trains the system rather than programming it, which is what we've seen before in the early parts of artificial intelligence. I'm getting quite technical here, but what it does is it's an algorithm that parses data, learns from that data, and then applies what it has learned to make informed decisions. So if we want to see that in everyday life, think about your Netflix account and the way that it gives you suggestions to watch a new television show that's been recommended. So what it does is it looks at all of your user preferences and what you've watched before and what you've enjoyed, like let's say the shows that you've watched from start to finish or through the entire series. And then it associates that with shows that contain similar information, similar kind of traits, and then matches that and learns from the use of you using Netflix to give you better informed decisions. So while that sounds somewhat complex, it's actually, again, quite limiting. It's only capable of doing what it's designed for, nothing more and really nothing less. So that brings us to the next stage, which is deep learning. And deep learning is why we have seen is where the real advances in automation have taken place in the last couple of years. And it's taken place because of three specific kind of, what I personally feel is three specific advances. And they are the advances in data that's available to us as individuals through data centers, the evolution of a thing called the GPU, or a graphics processing unit, and then a thing called a neural network. Now, I'm getting extremely complicated here and extremely technical, and I really don't just, but so just stay with me on this. I think I've got a very good analogy that will help you understand this. So what deep learning is, it's a subset of machine learning, as you can see from the image. And while machine learning needs to be told how to do something to make an accurate prediction by feeding it data, deep learning is actually able to learn itself through its own method of computing. It essentially creates itself its own brain. It's designed to continuously analyze data with a logic structure, very similar to the way a human brain actually draws out a conclusion. And I'm sure, a lot of you have seen images of kind of neural, or the brain network of these kind of electrons and electronic kind of messages going from one part of the brain to the other. It's sort of along those terms. And what it is, along a neural network. I'm just going to flick to the next page for 1 second to give you an idea of that. You see the deep learning neural network. It's very complex. It looks like some crazy science experiment that you saw in chemistry class back in high school. And would give most people a headache. But really what that does is that it allows someone to give great uncertainty on the balance of probabilities that something is correct. And how I'm going to explain that is quite simply in that if you think of a stop sign on the road, and if you think about taking a photograph of that image, and you think about how a computer would be able to recognize that stop sign, well, through machine learning, it would take the image and it would look at the image and it would see that there is a post with a red hexagon at the top of it. It would say that it's 6 feet tall. It would see that it's red. There would be an S, there would be a T, there would be an O, a P. And through about 8 to maybe 15 different variables, it would make a decision on whether or not that particular image was a stop sign. But the difficulty arises if, let's say, you have a red balloon in the tree, or you have a kite flying in the wind. That same computer would recognize that as a stop sign. Well, that doesn't really help anybody and doesn't really help in any sort of technology. So, it certainly wouldn't be helpful in a autonomous vehicle. So the next step of that is deep learning. And what that does is that with a stop sign, and we'll take that same image again, what it'll do is, through this complex structure that we've seen here, it will, like a brain, it will run through all of those 15 different variables, and it will run them against all of these other types of variables that it can figure out through an algorithm, to then equate that with possibly somewhere in the region of maybe 10 million different images of a stop sign through that it would be able to get its access to work out within the balance of probabilities of a 99.99% chance that it is a stop sign. Well, quite simply, that changes everything. And I know I've got quite technical there, but what that does is that it allows a computer to take an image and understand exactly what it's looking at. It gives a computer the ability to see, and I'm going to probably get in a little bit of trouble of saying that, but really that's what it does. It's image recognition. As we've seen through the 70s, 80s, 90s, 2000s, computing powers can be very, very strong. It's a brain. It's a brain that can work out things, mathematical equations, and be very, very strong. But what this has done, what deep learning has done, especially with image recognition and the advancements in the GPU, is it's given the computer eyes. So it now can understand what it's looking at. And that changes so many different things. I mean, the obvious one that's going to affect people, I mean, hopefully sooner rather than later, is the autonomous vehicles. You know, it'll help with traffic and different things, which will allow that. I mean, it's that image recognition that's going to change this. So from that, I'm just going to move forward. It's going to affect robotics. Now, this is the first part of the hardware element of automation. Well, robotics itself is, the first part is it goes through 3 different waves. And the first part is structured manipulation. So the 70s and 80s robotics that we saw, like, I mean, are all the precision robots that we described earlier, where you're picking something up at point A and you're bringing it to point B. Now, without image recognition, it couldn't do anything more than this. What it can do is, like, I mean, it works off lasers. I mean, to pick that point, that box up at point A and move it across. And, like, I mean, even though that with the emergence of AI through this particular time, what we saw was machines then being able to beat human beings at quite complex things, being like games of chess or Jeopardy. But these were very structured games in that there is only a finite amount of different variables within that game that can possibly happen. So what was perceived to be quite an intelligent thing to be able to do, it actually was not really that complex. But if you take much more of the kind of the more simplistic things that a human being can do, like walking or seeing or having a conversation, folding a towel, well, they've actually been the far harder things to automate. But through this new advancement of deep learning with automation, they're making big strides with that. To the next point of robotics, which is unstructured mobility. And this is where we are at the minute. So we're seeing the advancement of autonomous vehicles. And that's done through a thing with the process of LiDARs. And then on a far more simplistic level, we're looking at domestic robots within our own houses. I'm sure a number of you have had a Christmas present or two that have been delivered of the new iRobot vacuum cleaner within a house. What it does essentially is it maps out the environment of your home through a radar system and through an image recognition system to be able to figure out the whole layout of your house. And then from that, it's able to then use that information to keep moving forward. But what this doesn't do is it doesn't give it cognition. It doesn't give it the ability to think about things in a complex way. So if you think about, I mean, I always like to use the example of the Jetsons, the maid in the Jetsons. I don't think it was Judy. Judy was the wife, but the maid in the Jetsons was a robot, and she was able to clean and do all the things that we would love someone in our house to have. But what this technology at the minute would allow you to do is, yes, it would allow them to take a robot, to build a robot, to be able to clean the kitchen as it stands today. But if you took the robot out of a box and you pressed go on it in your living room, it wouldn't be able to figure out where the kitchen was. And it wouldn't be able to figure things out because of the situation that it was put in. So there are advances in robots that need to still actually move forward for we're going to see any sort of real advancement along the lines of the Terminator or the C-3PO. And that, I mean, that's the next component of robotics and where they're going to go. It's the ability to essentially automate anything that human beings can do, to be able to have a conversation back and forth, to be able to react in a simple and kind of knowledgeable way. But, you know, while I talk about this, I mean, as if there's an advancement in this, I do still think that we're probably 30 to 40 years away from any sort of real cognition within robotics. So that's all the technical stuff out of the way. So let's talk about something a little bit more kind of day-to-day and prevalent to everyone here listening in. So how is automation going to affect commercial real estate? Really, like, I mean, is it going to affect commercial real estate in any way? Should I care? After all, like, I mean, if you think about it, the way a building was built in 1981, it was built with steel and concrete and laborers and a crane. And then if you think about it, how it was sold by a real estate broker, like, I mean, by a guy or a girl picking up a phone and ringing their, top 3 clients and figuring out, like, I mean, were they interested in selling it? And it's not a million miles away, like, I mean, from 1981 as it is today in real estate. So why should, automation, why do I think, I'm hearing all these things, why should I care? I mean, nothing has really changed over all these years. The relationships that a broker has created through the course of their career is still the far most important thing. Well, let's try and think about it in a little way. I mean, automation, I mean, as I said, we've heard it all before, going back even back in the 1800s, we had the Industrial Revolution with the, the weaving loom and the combine harvester. These were all things that were supposed to, remove these particular people from jobs. And yes, it did. But then we had the next phase of automation, which was the computer itself. This was going to remove the end of assistants within the office and secretaries, and then the manufacturing workers of within an assembly line. So with real estate, how is it going to affect this? Well, the way I feel about it is I think that there's going to be three specific ways in which automation is going to affect real estate. The first off is the way we use buildings. Secondly, who in these buildings is it going to affect? And finally, the construction of buildings. Well, I'm going to start actually at the end here with the construction of buildings, because it's probably the least of interest to the listeners on today's webinar. But what that is the automation, the construction of a building. This here in front of us in this image is actually an image of the Halcyon robot being built at the minute down in Australia. And what this does is it's an automated bricklaying robot, quite simply. There's nothing kind of more fancy than that about it. Will it change the building industry? Possibly. Can it build any faster than a construction worker can lay brick? Actually, no. But what it can do is it can work 24/7. While a bricklayer can go home at night, and there's nothing taking place in the construction site, this can work through the night. So is it possible that this could change the construction industry? Possibly. But I think we've a little bit while to go with it yet. The next side of construction that's really making an effect at the minute is probably a little bit more on the residential side, so I won't spend too much time on it. But 3D printed construction is something that's becoming very, very real. We had the first 3D printed house last year, and while this is a rendering and doesn't look real, this is not a million miles away. This could actually take place far sooner than we think. It will just really come down to how cost efficient it will be to construct these types of buildings. So where are we now with construction? Well, this is quite a good image actually of the availability of technology that's on site. We don't have robotic workers, we don't have robotic Terminators that are on building sites. What we do have though is quite fancy equipment to be able to help the construction workers themselves. These here are both the ESCO body vests that help construction workers either support and lift things on site. Because you can see, they're hydraulic based, and they've become quite useful, I think, on construction sites of late. And this is where we really are with that. There hasn't been really any advancement as much as we think in the construction of buildings just yet, but it definitely is coming. Moving to things that are a little bit more relevant to where we are today for these people, but the way we use buildings is probably going to be the thing that is going to affect us with automation first and foremost over the coming years. It's the emergence of smart buildings that we're going to see. So that's going to be, asset and property management tools are really going to make a major effect on the real estate industry. It's the use of data and sensors that are going to be, allow for the creation of these smart building systems. It's really going to affect the property management, I think, as more so than anything else, in that if I've got quite a good example in that I was lucky enough to get a tour of the John Hancock Tower a couple of weeks ago, and I was in the boiler room where I was talking to the chief maintenance officer of the building, and he was explaining to me that they just put in a huge array of new sensors at quite a large, substantial amount of money. And then he explained. I said, was it worth it to him? And he said, it was. Not only was it worth it to him, they'd already made the money back within their first month. And how they've done that is the building that I'm talking about is close to 2 million square feet in size, and the bills for the HVA system there are regularly over $1 million a month. So where a case of, especially during the cold months here in Boston, when things can freeze and there can be many issues with these boilers, when you have a situation that you have the sensors and the data platforms in place to be able to understand that these boilers have the potential to break down, and then go out there and fix these boilers before they break down, well, that's worth an awful lot of money. It keeps everybody happy. It's a reduction in the property management sphere itself, and it also, it keeps the tenants of the building happy as well. So where, the smart building systems are really going to come into place, and where you're going to see an awful lot of development in the next 6 months to a year, is this concept of the smart workplace. The aim is actually going to be that, like, I mean, it's going to measure the productivity of the office workforce. Now, at present, that's something that is just impossible for the leasers of space to be able to do, to be able to actually come up with some sort of metric to understand how people in an office are really producing on a weekly or a monthly or a yearly basis within their office. But the idea is to try and work towards that as efficiently as possible. And quite a good example of that, of some of the tech I've seen recently, is, and this is on a far more simplistic way as opposed to the productivity outcome, is even quite simply looking at with sensors, being able to understand that a radiator in the corner of an office actually leads to more people moving away from that particular point in time. And from also the work that they were able to do, sorry, I've actually skipped a little bit, but I've explained that this is a company that I recently just had a meeting with. Their product was able to understand that by having a heat source in a particular point in an office, it led to less people wanting to spend time in that particular point of the office, and less productivity by movement of the people on the floor. But one of the major things that they were able to understand was actually that people's annoyance from an office manager sitting in an open plan environment. People seem to actually be happier and can produce more work when the office manager was behind closed doors, because they felt themselves as workers within the floor that they weren't being watched. So there are startups and companies out there trying to disseminate this type of information to create a smart workforce. And I think that's where you're going to see an awful lot of advancement and an awful lot of investment over the coming years. The next part of how these spaces will be used will be the effect of, and I'm just taking another example, is the effect of autonomous vehicles. Now, the effect of autonomous vehicles is a webinar in itself that could go on for at least another couple of hours. But one thing that people have to start thinking about now is, if autonomous vehicles are going to come into play, what are we going to do with all the parking structures in a downtown area? What are the real estate plays that we can make with that? You know, if you have a parking structure that's making money in a downtown area, is it possibly a new real estate development in the coming years, or is it possible to repurpose that structure itself without knocking the building down to some sort of new office environment? And this is a very good image of a concept that's come out of San Francisco for a particular parking structure. So these are things that people need to start thinking about, over the coming years. So this is the third component of it, and that is who will be using these buildings in future. And really, this is probably the most important part when dealing with clients, as a broker, because what jobs are going to be affected? Is the industry that you're in going to be full? Is it going to find itself being automated? Are the people and the staff that you hire going to actually be affected? If it's an industrial warehouse, are there going to be people working in it, or is it going to be just machines and robots? So these are all sort of things that that people want to have a little bit more of a concept. Here's a great image of an Amazon warehouse, whereby you have an entire warehouse which essentially will only have 1 or 2 people working in it, and it will be an array of these small robots, which Amazon, I think, have ordered close to 30,000 of in the last 6 months, to be able to distribute and move the merchandise within their warehouses around the place. So is this really what an industrial warehouse is going to look like in the future? So this is quite a good matrix to, and I don't want to get too technical, so I'll only give a quick summary of what this is in front of us. But this is a matrix to outline how jobs are going to be perceived. And it's a quick way of thinking about, is a job routine or is it non-routine? Is it manual? Is it cognitive? And essentially in the past, if you were in the manual and you were in the routine position of a job, like an assembly line worker, that's where we've seen jobs been lost to automation over the last 20 years. But the interesting component that we're going to see through this new type of automation and through this ability to be able to recognize and see things is through the manual non-routine and the cognitive routine types of jobs. So we're going to have 3 of these 4 quadrants that are going to affect the jobs industry. So my next slide is probably the one that's going to cause the most controversy. This is an impact of automation in a building life cycle. And this is something I put together, as an idea, in that if we think about the building of a life cycle itself, be it an office building or an industrial building, these are technically the jobs that are part of that are involved in the construction and the that work its way through the life cycle of a building. And what I've done here is, like, I mean, from pre-development right through to demolition. And I've outlined here a number of the jobs at those specific points in the lifetime of the building. The jobs in red are seen as the jobs that have the most ability to be automated in the coming years. The ones in blue have there's a question mark over, and the ones in black are the ones that are seen that will have the best chance of being able to deal with automation and, like, I mean, not be susceptible to it. You'll see broker is in black. If I was to, and I'm sure that's where it's probably going to cause the most controversy, in that I'm sure you've read many articles that, you know, this new wave of automation is going to lead to the end of the broker. I mean, and that brokers are no longer going to be needed. Well, from fundamentally the research that we've done, there's been an awful lot of, I think the main study on this is a guy called Frey and Osborne, who basically outlined that I think a real estate broker had an 80% chance of being automated. Well, yes and no, in that, yes, a lot of brokers' tasks are going to be automated, but they're going to be the simple tasks of generating leads and distributing marketing materials and putting things out there. Like, I mean, so the industry itself, we believe, is actually, it's going to become more constricted, in that it's going to be a little bit more the strongest will survive. But the guys that will be able to survive are going to survive because, quite simply, it's going to come down to human relationships. People don't want to spend $1 million on even a house, or $10 million on an office building, or $200,000 a month on a lease, without having some sort of human interaction to let them know that the decision that they're making is the right decision. They can't, like, I mean, if they're dealing with an auction website and they're dealing with some, you know, like, I mean, it's simply a computer screen telling you that this is the right thing to do. Well, that's okay for buying a T-shirt on Amazon, or a hockey stick on the Nike website. But when you're spending this amount of money, it's a life effect. If it's your home, it's going to be the place that you're going to live for certainly the next 10 years. If it's an office building, it's an investment of your money that, you know, is going to be part of your pension. So you need that human interaction to know. I'm going to use the word hand-holding, and I probably will get in trouble for that, but it really is. That's an important part of the human connection that we need to understand, that what we're doing is the right decision. So I feel, like, I mean, personally, that the broker has a very, very strong position. I think his tasks will get automated, but his position will get stronger. So it will be the younger brokers who will find it harder and harder and harder to break into that situation. So again, I'm just quite conscious of time, but so the impacts of automation, there's arguments for and against whether or not it is a good or a bad thing. This is actually a great idea of helping people understand automation as being a good thing. And it's the example of the ATM. When the ATM was first developed and circulated throughout the industry, everyone said it was the end of the bank teller. And employees in the bank literally fell from 20 per bank to 13. And, like, so it really was a reduction. But what this does is it allowed that the running costs of a bank became far, far cheaper. And so the banks were able to open far more branches. In fact, they opened nearly 50% more branches, which created far more employment through the use of the ATM than it did for anything else. So it's the evolution of the jobs that, yes, jobs will be lost, but there will be so many jobs created on the other side of things that no one has been able to think about yet, like, I mean, that will help automation. These are the guys I was referring to earlier on, against automation. They've outlined their ideas that 50% of jobs are going to be susceptible over the next 20 years. Personally, I don't think it will be close to that. I think if you think about jobs on a task basis, you're going to have a far greater understanding of whether a job will be automated or not. If it's an assembly line worker, you can obviously understand it. If somebody's job only involves one task or two tasks, then there's quite a good possibility that the job will be automated. But if you take a real estate broker, or you take a lawyer, or you take an architect, certainly one, like, I mean, that's, like, I mean, runs his own company. Well, like, I mean, the tasks that they do on a daily basis is numerous. They're running an office, they're meeting people to evaluate things, they're trying to design a transaction as well. Well, like, I mean, that at the minute, that's going to be very, very hard to automate. So this is also a very good image, I think, in itself, of how today's employers are, like, I mean, in the tech industry, are affecting the office and the the industry, the industrial warehouse industry. These are the big tech companies that we've all kind of come very, very familiar with. Well, if you just look simply at their valuations, like they're astronomical. And if you look at the amount of employees that they have, well, they're nothing close to what we've seen in, you know, in the industries of the Dow Jones, like, I mean, of the big industrials over the last few years. Like, look at GM. GM is it's a household name within the United States. At one point, it had close to 800,000 employees, and still today has a valuation of 50 billion. Like, Facebook and Google are mammoths in comparison to it. And then you have these other, like, I mean, new industries like WhatsApp and Instagram. Like, Instagram was sold for $1 billion. It had 13 people working for it when it was sold to Google, or to Google. It's just incredible. So where are the jobs of the future? You know, this is an image of people standing in line with robots. I really don't think this is where automation is going to lead to, or I mean, for most people, but it is a very, very interesting topic. So what does the future of the workforce in an office building or an industrial building look like? It's going to be very, very interesting over the next years to see how it all works out. So simply, I think that's where I've come to a conclusion. And Lizzie, I'm ready to take some questions if there's any out there.
We will now have our question and answer segment of the program. To enter a question, simply type your question in the question box and click on send. Okay, we have our first question, which is, how would you look at automating the brokerage business, and how should we think about tasks that AI can replace?
Great question. I think there is an awful lot of tools out there that are going to be extremely helpful to the brokerage business. The brokerage business is a funny business in that if you're not in the brokerage business and you're in real estate, it's the industry that people would love to see people break in a funny way, because, you know, there is people that are out there that really have their, not issues with brokers, but it's a fee that they feel like, I mean, sometimes that they could get away with. But fundamentally, I think brokers themselves, you know, they generate so much information, and it's trying to, I think brokers should be aware that that information that they hold is of real value. So, I mean, the things that should be automated are the tasks that take up a broker's time that really don't lead to any real value, whatever that is. If it's a case of, you know, creating lead generation or marketing a particular property, if you can reduce the time that a broker has to spend on that, I think they're the ones that, I mean, I would look at, because fundamentally it's when you're sitting down with the person who's really in charge of making the decision. That's where the broker needs to be spending time on getting the deals done in front of the person who's willing to spend the money. I hope I answered the question.
Our next question is, what technologies should brokers look at most closely over the next 12 months to increase productivity?
I'm quite conscious of naming out specific technologies on the webinar, so I'm not going to do that. But if I was to make a suggestion, I would look at the resource center of the SIOR, which we are. I'm working with Alexis on at the minute to outline all of what we hope are the best technologies in 5 or 6 certain areas of the industry, with one very much specific to brokers. So over the next few months, I would keep an eye on the SIOR web page, especially the resource part, and I think from there you're going to just find yourself with some fantastic information, some fantastic products that are available to you.
Okay, are new garage structures being built with a planned reuse in mind? It seems very difficult to renovate a garage. Very much so. I mean, and it is, and that's where without question, it's one of the things that they're far smarter people than myself are trying to figure out, because of the difficulties involved. Especially there's certain types of garage that, especially the ones that have the slanted surfaces going up and down. They're going to be extremely difficult to maneuver. So it's personally, I don't know how it's going to work out. Is it the creation of large co-working spaces? Could that be done?
Is there a potential to use the space for, and I'm saying some crazy thing. I mean, research and development is not something that they'll be able to do because of the height restrictions most of the R&D labs would require on them. They wouldn't be able to put the HVAC systems in. So it's really, it's coming up and it's the person who comes up with the most imaginative creation for using those parking structures that's going to find themselves in such a unique position, because there's so many people out there thinking about it, but no one has been able to come up with something really of any real value. I mean, knocking it down is obviously the very simple answer, but I think you will find that there are a lot of people working on this trying to create something really, really special. I just don't know what that is. If you look at I don't have the ability to do it here, but there's some fantastic examples of using large open spaces that, like a parking structure in Europe at the minute. One in particular is, I think, called District H in Paris. And what they've done there is they've created a co-working and incubation kind of center. I think it could be something along those lines that would probably see the most advances in the parking structures.
Okay, what is the best way to collaborate with artificial intelligence to obtain resultant brokerage goals?
Ooh, what is the best way? That's a great question. First of all, I would fundamentally sit down and try and figure out what those goals are as a starting point. And then I would try to work around my own situation to figure out what data do I need to be able to get those goals. What is the data? Because it's everything is revolving around data. And if you can figure out what your specific goals are, and then figure out, how do I get to that? What are the 3 or 4, 15 different data points that will get me to understanding that little bit more than my competitor? That would be the way I would look at it. Because when it comes to when it comes to transactions, yes, there's the CoStars of this world, and there's the large data providers, but there is competitors out there as well, trying to provide this. A lot of it with publicly available information. So if you try and figure out the data points that are going to help you, and then try and figure out where you're going to where you can attain that information, that's where you're going to find the ability to use AI in a far better way. I mean, through the programs that you're going to be able to buy, and also fundamentally through parsing that data together for yourself. You don't necessarily maybe need a program if you can understand something from working out the data that you've been able to take in yourself.
What do you see as the broker's role as consultant, and in terms of moving towards smart buildings, connected buildings, and integration of technology, for example, BIM?
Having an understanding of the building and the costs it's going to require the owner to implement these technologies. So all of these smart buildings are, a great idea, and it all works very well when you're building a new construction from the ground up, because you'll be able to implement all of these sensors and data points within the building. But really, most of the things that most people will be selling buildings that have been around a long time. So it's trying to figure out what is the cost of implementing these types of software and data centers within a building to make it more beneficial for your client. And obviously, when you come to a point where if it's more expensive, if it's not worth it, then you won't do it. And if it is worth it, you will have the expertise to have that, be able to price that for your client and try and implement some sort of system within it.
Right. Do you foresee redesign of basics such as shipping containers and truck trailer design that would lead to new designs of loading areas, truck courts, and industrial building placement?
Oh, we've seen an awful lot of it already. In any cool hipster bar in around a lot of cities, in kind of not so much waste areas, but areas that have had issues with planning or entitlements, and you'll see bars spreading up in shipping containers, and you'll see double height shipping containers put together to create some sort of fun kind of environment. So people are quite imaginative with these things. As regards a transportation reevaluation, I think, honestly, if I was looking at it, I think when it comes to autonomous vehicles, the thing that we're going to see quicker and sooner rather than anything is the autonomous trucking. So I would look at it along those lines. How is the autonomous trucking going to affect let's say when it comes to an industrial warehouse building or some sort of R&D lab building that needs large turning circles and large turning areas to be able to load these trucks. How are they going to be? How are these autonomous trucks going to be able to work and manage within those confines? If they can't, or is it a case that maybe there will be some sort of depot outside of a city that will be, that the autonomous vehicle will bring it to, and then you'll still need a truck driver to bring these into these kind of more acute turning areas. I would look at the autonomous vehicles to see what sort of options there is with that, because it'll be buildings that have the capabilities to basically allow autonomous vehicle or autonomous trucking work within the buildings that are going to probably have far more value over the coming months. Coming years. It's not months away, it's years.
Are there construction standards discernible today being used by companies such as Amazon that could be implemented by developers today in anticipation of automation, such as robotic pick and pack? For example, floor slab, clear height, building dimensions, column spacing.
I'm not sure if I understand the question. Like, I mean, if Amazon are using these things and people know about them, the money that Amazon put into these things and the research and development that they do is second to none. So they've obviously looked into whether or not these things are the right thing to use. So I'm a big believer in following Amazon in a major way. This is probably a little bit off topic, but I've had a couple of people I work with been lucky enough to go to the Amazon Go store out in Seattle recently, and if there's ever a game changer in the industry, that's probably going to be the thing that's going to affect people on the street the most. The idea of walking into a shop, picking up the groceries or the things you need in a store, and walking out without having to go through a checkout or a cash register, and it just working off this fantastic technology that they have in the ceilings. Well, I mean, the guys, when they were walking out of this particular this new concept, they asked them, you know what I mean, how do you see this? How do you envisage this in the next couple of years? Do you think one in every city? And they said, well, not really. We kind of, just think about it more of in the case of, like, I mean, how many Starbucks are out there? Well, we want to be bigger than them. I mean, with corner shops. So, Amazon are at the forefront of enough. Like, I mean, it's why their stock price is so high. It's why the analysts put their growth is so big on the market, is because there's so many things coming out and they've thought about things in the future far more than anybody else. So if they're doing something, I would think that it's right up there as something to implement.
Unrelated to real estate, how much of an impact will new discoveries of automated learning have on concerns about control and safety in the future? And are concerns about future control and safety warranted?
Very much so. I mean, I don't think there's a construction company out there, a construction company of merit, or a construction company of any size, that if you talk to any of their foremen or their C-suite, I mean, safety is the most important thing on any. And I'm talking about probably construction here more so than anything else. Maybe I missed the question. Maybe it was buildings, but for guys that work in the industry, I mean, safety is actually the number one thing that they look at. Like, I mean, if you talk to any of the guys at the top, they lead from the front. You'll never see like a guy, within a construction team, even if they're dressed in a suit, going out on site with the leather brogues and shirt and tie. They have the safety equipment on themselves. They lead from the front. And I think, I'm not sure if that comes down from experience of bad things happening on sites in the past or what that is, but I mean, even in today's market, any site that I've ever been on, safety is paramount, and I don't think that would change through automation. I think in fact it would become even a stricter policies more so than anything else. I'm not sure if I answered the question. I'm not sure if it was related to buildings or construction.
Do you see government buildings as models for futuristic design? Reason being that they are publicly owned, held long-term, and not sold upon lease-up and stabilization?
Well, that's a really opinionated question. I don't know if any of you've ever been in I was in City Hall yesterday, which is obviously where the mayor sits here in Boston. And it's a great example of brutalist architecture. Someone was trying to explain to me, which was, it was that raw concrete style of the late 1960s. And while it was used for, it's a great example of something brilliant and bold at the time. It's not everybody's cup of tea today. So it's a really tough question, but I'm always a fan of new invention and things moving forward and creating new ideas and new concepts. So I would love to see that personally.
Okay, it looks like we have one last question, and this relates to your remarks about data. This person's wondering, how does the SIOR community retain control of and consolidate their data rather than buy it from third parties? And what should the SIOR community be doing about this?
Well, that's a brilliant question. And it's one, unfortunately, that poor Jim Klein has had to deal with many conversations with me about, and he's got a headache with me annoying him about it. I personally would love to see the SIOR use the data that it has. I mean, its members have firsthand the real raw data of value at their fingertips. And to be able to utilize that, whether it's for their members or whether they bundle it together and they sell it off in some sort of mini CoStar fashion, I think is a tremendous idea, and it's an opportunity that the members of the SIOR should really look at. Fundamentally, like when it comes to a transaction, you know, because you're the brokers that are dealing with it, you get to you have that information to hand. You know the marketplace, whether or not things are moving fast or slowly, and I mean that puts you in a very special position. There is obviously major logistic issues with confidentiality. There's major logistic issues with competition, but you know, with the fact that the likes of these mammoth information companies such as CoStar charging the amount of money that they do, which is it's quite hindersome. I think there's a real opportunity for the SIOR to bring together and come together as members to create some sort of we'll call it data conglomerate, and use that for their own interests first of all, and then secondly, as a completely separate option, maybe putting it together and selling that information to outside parties.
Okay, and we'll take just this one last question. The problem that we are having in designing buildings, infrastructure, and transportation for the future is in modeling it. How does one model something like autonomous vehicles and connectivity that has never before existed?
It takes very, very, very smart people, and it takes I don't want to get into some crazy stuff here, but there's fantastic things that NASA actually developed, a thing called a digital twin to run these. Because when you have a situation like if you take NASA and you take a spaceship, well, when a spaceship goes off into space, people in NASA can't work from it. They can't make any alterations to the spaceship because it's no longer in their hands. So what they do is they have to build a digital twin in a digital sphere and then run scenarios against that digital twin in order for the astronaut or someone to be able to work against, to kind of create ideas for them to. I've just lost my train of thought there, but the astronaut will then have the information from NASA based on the scenarios that they've run against this digital twin to work out whether or not it's good or bad or whether it works or not. So using that system, I think an awful lot of the smarter people, I mean, certainly in the regulatory and in the logistics sphere of both autonomous vehicles, will be running scenarios through things like that to be able to understand the systems better and quicker. But like everything, there's nothing like hands-on or first or experience or the ability to work with things in reality. So it's going to be a difficult one. Like yourself, like I mean, while Elon Musk will be able to say that this car has traveled for 5 million miles without any issue, there will be a day when an autonomous vehicle will have an accident, but be it hopefully, like I mean, it's only a small accident and no one is hurt, but there will be that day, and because something will have happened that no one thought of, and no one will have put that scenario in place. So we'll have to deal with it like we deal with everything else. We'll in as kind of a smarter way as possible.
Okay, well, with that, we will conclude today's webcast. Thank you, James, and thank you to the SIOR Technology Committee for putting on today's program. We appreciate all of your participation in today's webinar, and the recording will be available on the SIOR website. You may now disconnect.